In this video, we will talk about how to find the area of a segment in a circle. So let's check out an example. Let's say we have this circle here, and let's say we want to find the area of this shaded in segment. So just as a definition, a segment is the area between a chord and the circumference of a circle. So a chord is just any line that connects one endpoint of a circle to another endpoint. So this line we have right here, this is a chord. And a segment is the area between this chord and the outer edge of the circle, or the circumference. So this shaded in area represents a segment of a circle. So how can we find the area of that segment? Well, there are two things we need to know. The first is the radius. So the radius is the distance from the center of the circle to the edge. So let's say that this radius right here is 6 centimeters. Notice that we can form another line right here connecting the other endpoint of this chord, and this must also be the same radius. So this must also be 6 centimeters. So we need to know the radius. We also need to know the central angle. So that's the angle right here formed by creating these two lines. So for this example, let's say the central angle is 120 degrees. These are the only two things we need to know to figure out what is this segment, what is the area of this segment. So let's check out this three-step process that I've written here. The first step is let's find the area of the sector. So the sector is the total area formed from both radii and the circumference of the circle. So we can imagine it as this big slice of a pie. This whole area represents the sector. What we're going to do is find the area of this sector, then we'll find the area of this triangle that we formed right here, and then we'll subtract the area of the triangle from the sector, and we'll be left with just the area of the segment. So let's do that. So to find the area of this whole sector, here's the formula that we can use. The central angle divided by 360 times pi r squared. So in this example, the central angle is 120. So all we're going to do is plug in 120 right here. So let's say step 1, we'll do 120 divided by 360 times pi r squared. R is the radius, which we said is 6. So we'll write a 6 squared. So what do we get? So 120 divided by 360, we can cross out these two zeros. 12 divided by 36, that's 1/3. So we'll say 1/3 times pi. 6 squared, that's 6 times 6 is 36. So let's see how we can simplify this. 36 times 1/3, that's 12. So we'll say 12 pi. That's the area of this sector. Now if we want, we can punch 12 pi into a calculator to convert it into a decimal. And when you do that, you get about 37.699. So that's step 1. We found the area of the sector. Step 2 is we need to find the area of the triangle. So notice that between the two radii and this chord right here, we have a triangle. And here's a formula that we can use to find the area of any triangle if we're given two sides and an angle. We can do 1/2 times A times B times the sine of C, where A and B are the two side lengths that are given, and C is the angle between those two side lengths. So notice that we're given that this side length of the triangle is 6, and this side length is 6, and the central angle is 120. So we have everything we need to plug into this formula and figure out the area of the triangle. So let's write step 2. We'll use this formula. 1/2 times A, so A can be 6, times B, B can be also 6, times the sine of C. So remember, that's the angle between A and B, so that's 120 degrees. So we get 1/2 times 6, that's 3, times 6 is 18. So 18 times the sine of 120 degrees. When you punch that into a calculator, you get about 15.588. So remember, that's the area of this triangle right here. So the very last step is we just need to subtract the area of the triangle from the area of the sector. So we can say 37.699 minus 15.588. And that turns out to be 22.111. And remember, the units we're working on are centimeters. So we'll say centimeters squared since we're talking about area. So the area of this shaded in segment right here of this circle is 22.111 centimeters squared. And we figured that out using only the radius and the central angle. So you can use this same process to find the area of a segment in any circle.